Hi guys, I wanted to record a quick video going over the Marshmallow Lab that you're going to be doing at home. So first of all, I want to go over some basic information in terms of Earth structure. So when we look at our cross-section of our planet, I can draw in here, okay, so if you can imagine going deep into the very center of the Earth, we have our core, right? Beyond the core, we have our mantle, okay? And above the mantle, we have the crust. Now remember from our previous recordings that within the core itself, we have a lot of radioactive decay going on, all right? And as a result of the radioactive decay, we have a lot of heat that's being transferred into the mantle, right? Because it is very, very hot in there. Okay. Now, within the mantle itself, what happens is we have what's known as the convection currents. And convection currents work in a way that hot material will rise, okay? Hot material will rise, and then as it rises, it will lose some of that heat and become more dense and fall again back towards the core itself, okay? So there's this constant exchange of material between the lower mantle and the upper mantle. Now those circling matter will actually be the one that drives the crust to move or slide on top of that upper mantle. Okay, so the convection currents will actually allow us for the movement of crust. Okay, again, as the hot material rises, it rises because it's less dense. As it rises, it will cool off and then become more dense and fall closer to the core itself. So what happens is we are going to be using your materials today to demonstrate that and to demonstrate the different plate boundaries within the Earth's crust. Okay, so you have gotten a couple of things, a little baggie with your materials for the lab. You have your graham cracker and your cup of marshmallow fluff. What you're going to do is you're going to take your big piece of graham cracker and break it into the following parts. You're going to have 1/2 of that big graham cracker, and then the other half you're going to break into halves again. Okay, so you're going to have 1/2 and then 2/4 of the graham cracker. The smaller pieces of your graham cracker are going to represent the lithosphere. Okay, the lithosphere is the outermost part, which is the crust. Okay, the lithosphere also will encompass the uppermost part of mantle. But what we're going to do is you're going to put that marshmallow fluff on top of your bigger piece of graham cracker, and we consider that the asthenosphere. Okay, and that's the more rigid part of the mantle. Okay, so what you're going to do is you're going to put, going to take your larger piece of graham cracker. Okay, you're going to fill the surface with your fluff. Okay, so this is your fluff, and then you're going to place the other 2 pieces of graham cracker on top of that. Okay, like that. And then your goal is to manipulate those 2/4 pieces of your graham cracker on top of that marshmallow fluff to represent the different plates that are gliding on top of that molten material within the Earth's structure. So you're going to demonstrate 3 different types of boundaries, right? We have our transform boundary. And if you remember from our previous notes, our transform boundaries are happening when we have 2 plates that are sliding past each other. Okay. Then you will have your convergent plate boundaries, and those are boundaries of plates that are coming towards each other. Okay, they're coming towards each other. And lastly, you have divergent plate boundary, where the 2 plates are separating from each other. They're coming apart. Okay, so that's pretty much what you're going to be working on in this lab. Manipulate the top pieces of your graham cracker, and then observe what would happen to that marshmallow fluff underneath. Okay. If you have any questions, send me an email or a text through Remind, and I will be happy to answer your questions. But I find that this lab is pretty self-explanatory. Students are doing fairly well on it at all times. For the questions on the last page, when it's asking you for examples of locations of the different types of plate boundaries and what Earth's feature you may find in that location, think about things like mid-ocean ridge. Okay. Think about volcanoes. Oops, volcanoes. Think about earthquakes. Okay. Think about trenches. Okay. Think about fault lines. Oops, fault lines, etc. So those are the things that I'm looking for you to be able to identify within the different types of plate boundaries. Again, if you have any questions, let me know and I'll be happy to answer them for you. I will see you in class.